All right. It looks like we have most folks, or our participation numbers have stabilized. So one final time, welcome to everyone for joining us for this webinar, Reproducible Workflows with IPUMS CPS and the IPUMS API.
All right, thanks, Kari. Yeah, my name is Renee Rogers, and I'm going to be talking to you all today about IPUMS CPS and the IPUMS API. So before we, let me stop my video here. Before we jump into our main topics, I just want to give you a quick outline of what we'll be covering today. So first, I'll give you an overview of the IPUMS CPS data and the example use case that we'll be referring to throughout our discussion. And then we'll turn to a discussion of sustainable workflows, what they are, how to set them up. And if you are an advanced data user, or if you have a fair amount of programming experience, some of this may be review. So please just bear with me for that portion. And after that, I'll give you a brief introduction to APIs, and finally talk about the IPUMS API specifically and show you how to use it in our IPUMS CPS workflow example case. All right, so the example, we're going to talk about poverty rates using IPUMS CPS. So our task is going to be to examine poverty over time using both the supplemental poverty measure, or SPM, and the official poverty measure, or OPM. And in this example, we will calculate poverty rates using both of those indicators for each year in our data, and we'll visualize how these rates change over time. As many of you already know, the Current Population Survey, or CPS, is a monthly labor force survey. And one of the most used CPS files is the Annual Social and Economic Supplement, or ASEC file. And these data are collected every year in February through April. So they're actually being collected right now for 2023. Very exciting. And the ASEC survey asks respondents questions about the previous calendar year. So the data that's being collected this year in 2023 is going to ask respondents to give information about the year 2022. The poverty information, which we are interested in for our example, is only available on these ASEC files. So that's the data that we'll be using. And as I sort of alluded to earlier, there are two different poverty measures available in this data, the supplemental poverty measure and the official poverty measure. And these measures differ both in their unit of analysis. So the official poverty measure uses family units that are related by blood, marriage, or adoption. And the SPM uses a slightly more inclusive resource unit that also takes account of co-resident unrelated children and unmarried partners, among others. And these measures also differ in the way that they calculate poverty thresholds and what resources they include to determine whether a given unit is above or below that threshold. All right, so with that set up, let's talk about workflows. So what is a workflow? It depends on who you ask. A workflow is a system of managing repetitive processes and tasks which occur in a particular order. A workflow is an end-to-end process that helps teams meet their goals by connecting the right people to the right data at the right time. But the definition that I prefer is just the method you create to get stuff done. And this is a very broad definition. And this also means that clunky, inefficient, or self-sabotaging ways of getting things done also qualify as a workflow. So what I hope to convince you of today is that making your workflow sustainable is worth the effort of doing so. So why are sustainable workflows important? Sustainable workflows are less error-prone. They're easier to debug when we do make mistakes, as we will inevitably do. And they make collaborating easier, both with yourself and with others. Right, it's a pretty common experience. You submit a paper for publication and you don't get feedback for several months. But when you have to return to that work after months of your life having moved on, you sometimes wonder, well, what on earth was I thinking? Why did I do this way? What am I even doing here? And so setting up a sustainable workflow, your future self will thank your current self. for setting that up so that you can easily return to work and remember what it was you're doing, take that feedback into account, and move that publication out the door. Right, and for a lot of those same reasons, sustainable workflows make collaboration with others easier. The same things that are going to help future you understand present you's headspace is also going to help a present day collaborator understand present day you's work. Okay, so before we get into more details of what makes a sustainable workflow, I do want to flag that these principles are applicable regardless of what programming language or statistical software you prefer. When we return to our example, I'll be stepping through some code in Python because that is what is most comfortable for me. But all of this can be applied to R or Stata or any other language or stats package that strikes your fancy. Okay, so with that in mind, what's a sustainable workflow? A sustainable workflow is one that is flexible, organized, and reproducible. So we'll go through these one by one. A flexible workflow is one in which it is easy to alter or update inputs. So for example, we can apply the same set of steps in the same order to different months or different years of IPUMS CPS data. It is easy to apply the same functionality to a different set of inputs. So for example, we can calculate poverty rates using different poverty measures, as we are going to do in just a minute. And it's easy to add or subtract steps or correct errors. If we make a mistake in a step that is applied multiple times, we only need to make a change in one place for that error to be fixed. Organized. First, and perhaps obviously, steps should proceed in a logical order. Your steps and functionality should be well documented, and this can be as simple as just annotating your code with comments to help yourself and anyone else who looks at your code understand what you're doing and why. And it also helps to give functions descriptive names, and we'll talk about that more in a little bit. All right, and finally, reproducible. So a reproducible workflow, given the same inputs, will produce the same outputs every time. And this, again, may seem obvious and simple, but depending on how you get your data and how you set up your data, this can be trickier than it first appears. And we'll talk about that more when we get to our discussion of APIs. Okay. So with those sort of general high-level concepts in mind, let's apply this to our example. So just as a reminder, our goal here is to look at poverty rates using the different measures available in the CPS ASEC and calculate rates over time and visualize those rates. All right, so the first step in this, as in any data analysis workflow, is to get our data. For those of you familiar with the IPUMS CPS website, you'll notice, or you will recognize rather, these little screen grabs over here as our website. So we'll go to that website and we will use that website to select our samples of interest. In this case, we're going to choose the 2010 through the 2021 ASEC samples. The supplemental poverty measure only became available beginning in 2010. So that's where we'll start our analysis. Then we'll use the website to select our variables of interest, which for our example are going to be the SPM poverty indicator and its weight, and the official poverty measure indicator and its weight. Then we're going to submit that extract and wait for it to be processed. And then we're going to go to our download and revise extracts page and download our extract file and any accompanying syntax files or metadata, and then decompress the data. So 6 steps just to grab our data. And then we'll read in the data. Again, I'm going to use Python. Doesn't matter what you choose. All of this is applicable across languages and packages. All right, so then we'll clean up, tweak, modify, and otherwise organize our data. I don't want to brag, but IPUMS CPS data is already pretty clean. So we'll just take care of the difference that I mentioned earlier between survey year and reference year. So recall that the ASEC data asked respondents about the previous calendar year, so data collected in 2021, describe the year 2020. So that's just what I've done here. I've created a new variable called survey year, set it equal to the IPUMS CPS year variable, and then modified the year variable by subtracting 1 from survey year. Okay, so now let's get down to what we actually wanted to do, which is calculate poverty rates for each of these years. So here I am just from our IPUMS CPS data, I'm selecting records that appear in the year 2020, and I'm summing their SPM weight values to get my denominator. And then here doing the same procedure, selecting on the year 2020 and just those individuals who are in poverty according to the SPM measure and summing their SPM weight values. And then dividing those out to get a poverty rate, and got a little print statement here to show me the results. But remember, we wanted to do this for the official poverty measure as well. So here I have added some code to do the same procedure with the relevant OPM variables. So in this case, what we're changing here is the weight variable. We just want the normal ASEC weight, and we're using the off-POV indicator to select folks who are experiencing poverty. And again, we've got a little print statement to show us the results. And remember, we want to do this for every year in our data, which in this example is 2010 through 2021. And here we've repeated the process for 2 years. And you can already see how this is becoming awkward, right? Very cumbersome, unsustainable, if you will, right? It violates all of the rules of sustainable workflows that we just discussed. So why is this not good? First and foremost, it is error prone. You can see I've already made a typo here, and I'm only on year 2 of 11. Even worse, notice that my mistake didn't actually cause an error. It still calculates a poverty rate for me. It's just wrong. So that's not great. This code is very difficult to debug. Finding that tiny typo is non-trivial, especially when you remember that we have 9 more of these blocks to go. So how likely is it that I made this mistake more than once? Like, pretty likely. And finally, this code is very unclear. Having large repetitive blocks of code makes it very difficult to read and hard to decipher. I wrote this code, and already just looking at it, like, my eyes are glazing over. And this makes it hard either for our future selves or for our current collaborators to understand like what it is we're doing and why. And finally, in addition to the code not being super clear, this output is not actually very helpful. It's not very readable or very usable, right? If we wanted to make a figure of this, we might end up copying and pasting these values into Excel, which gets real old real fast and is also very error prone, speaking from experience. I will also just say, like, all of these sins are absolutely ones that I have committed. Okay, so how can we make this better? Whenever you find yourself copying and pasting with just minor tweaks, you should start thinking about a for loop. So a for loop will perform logic for each value in a list of values in turn. So in our example, what we'll want to do is to loop over each year in our extracted data and calculate the SPM and OPM rates for that year. So here is what that for loop might look like. It performs exactly the same steps that we were doing in the previous slide for each year of data, starting with the first year of data in our, the first year value in our data, and proceeding in 1 unit increments to the largest value of year in our data. And you can see that this is already a huge improvement in terms of the number of lines that we need, the number of lines of code that we need to accomplish our calculations. Notice also that the typo that I made on that earlier slide is not actually even possible in this setup because I'm only specifying year in one place up here in this for statement. So that is already like a pretty nice thing, right? So even though this is an improvement on our previous code, this output here is still not super helpful. It's difficult for our eyes to parse, and it isn't easy to view trends over time. So how can we make this even better? We could put that logic for calculating poverty rates into a function. And doing this allows us to change multiple parameters at once, as opposed to that for loop where, let's back up here. Here, really the only thing that we're changing with each iteration is that year value. But we have a couple other things which do change within this block, specifically the poverty indicator and the weight variable. It also allows us to get better output. We have more control over our output, and it's just easier for us to make use of it. We can get a data frame for poverty rates instead of just a series of print statements, which is not very useful. And if we give our function a descriptive name, we will get more readable code. All right, so here is an example of what that function might look like. I'll talk through this and then we'll apply it to our example in just a minute. So here we've defined a function called getPovRate, and it does what it says in the name. It takes our data and the name of our poverty variable and our poverty weight as arguments. And then it performs the calculation of those poverty rates using pardon me, using our specified inputs. So you can see this logic is pretty similar to what we were doing before, summing the values of the weight to get a denominator, summing the value of the weight for those in poverty to get a numerator, and dividing it out, and then the function returns the poverty rate back to us. Another thing that we could do to make this even more flexible is to make the value that indicates in poverty status an input, a user-controlled input to our function. So here you can see this line that calculates the numerator requires that the value indicating someone is living in poverty is 1. And in our data, that is true, and so that's maybe not a huge deal. But if we pull that value out and make it an argument to our function, then we can apply the same logic to maybe a different poverty variable that we got from a different source that has a different coding scheme, and we'll still get correct results out of this logic. So we can reuse this logic in more situations. All right, so here we're applying that getPovRate function to our data for the SPM case. So here again, this IPUMS CPS DF is just our extract data, and we're grouping that by year. So for each year, each value of year in our data set, we're applying this getPovRate function using the SPM pov, SPM weight, and value 1 as arguments. And you can see this output is infinitely more readable than my series of wordy print statements, which is great. And we can do exactly the same thing for our official poverty measure. And you can see this is basically identical to our previous slide, except the inputs to our getPovRate function are the official poverty measure variables. And again, we get a nice sort of data frame output here. And another nice thing about that data frame output is we can use it to make plots pretty easily. So here you can see with just a few lines of code, I've got this nice plot that compares the supplemental poverty and official poverty rates for all of our years of data. And another nice aspect of this approach is how easy it is to extend our analysis to new similar variables, right? So imagine in a couple years, the Census Bureau releases a new experimental poverty measure, and you want to see how that compares to what is currently available, right? All that you need to do is apply this getPovRate function for the new variable and the weight, and then add 1 line of code here to add it to your plot, and you're done. Right? So if that happens 2 years from now, we could come back to this code and know exactly what we were doing and know exactly how we would want to modify it to extend our analysis in that way. So that is really flexible and really nice for us. Right, so all of that work that we did to simplify, condense, and organize our code got us to a much cleaner, more readable, less error-prone result. Our workflow is now flexible and well organized. And as I mentioned, we could easily return to this whenever there are new poverty measures to examine, and we could quickly and confidently get good results. All right, so before we jump into APIs, I'm going to pause there just in case there are any questions about any of the workflow stuff before we move on.
Yeah, Renee, can you hear me?
Yeah, I can.
We had one question about working with complex survey data in Python. Do you have any recommendations for good packages or modules for working with things like replicate weights in Python?
That is a very good question. The short and disappointing answer is no. That is actually one of the not great things about using Python for survey data is there isn't like an equivalent of survey or survey R that exists in R, or like the SVY stuff in Stata. With IPUMS CPS, that doesn't, so replicate weights are only available for some samples in the CPS. So if you're not working with those, it doesn't really matter because CPS doesn't really have a complex, well, it has a complex survey weight, but the PSU information that you would need to use those sort of complex survey data analysis packages is not publicly available. So yeah, if using those complex survey weights is a thing that's important to you, you should choose R.
Thanks, Renee. And then one other small detailed question was about the handling of missing values in the SPM and OPM variables. Is there anything that users should be aware of with watching out for missing values, or how you would filter those out?
Yeah, so in our in the IPUMS data, there should be no missing values for either of those measures. They're binary, either you're in poverty or you're not. But if there were missing values in our calculations, or rather those shouldn't impact our calculations if they've been made to be actual missing values, because pandas will ignore missing data by default if you're like summing or averaging or whatever. Did that answer the question?
Yeah, I think so. There was just a question about how do you how would this workflow deal with missing values? So
Gotcha.
But yeah, that's always a good reminder to be aware. I know in my experience, you always have to remind yourself to watch out for missing values.
Yes, for sure. And I should also say that the IPUMS variables often have actual numeric values that indicate missing, or like different flavors of missing. So it wasn't very necessary for the example that we were just doing, as I said, because our variables of interest are binary, they're just zeros and ones. But if you do have other data and you want to be sure that missing values are ignored by your aggregating operations, you should be sure to replace those with like a NaN value or something. All right, anything else before I move on to APIs?
Well, there are some more questions, but I think let's maybe save them so that you have a chance to get through the API stuff.
Okay, great. Yeah, we'll have time for questions at the end as well. So, all right. So, oops. All right, APIs. So this webinar is supposed to talk about APIs. Why am I yammering on at you about sustainable workflows? And I think that using APIs to get data is actually really important to making a sustainable workflow, because it makes our workflows reproducible, or levels up the reproducibility of our workflows. So to come back to our IPUMS CPS example, if you remember our first get data step, there are a lot of steps here. A lot of them require browsing, pointing, clicking, waiting, followed by more pointing and clicking, sometimes on a different page. And so using the IPUMS API to retrieve your data can first help you streamline these tedious steps when you know exactly what it is you want. And two, can make it so that someone else can reproduce your results without needing to reproduce your pointing and clicking, which is great if you're, again, trying to work with someone or submit a replication package to a journal. It just makes things a lot easier for those folks. So I will, before I continue, a quick shout out to my colleague, Derek Burke. These slides are from him, so thanks, Derek, for letting me share these today. So first things first, what is an API? API stands for Application Programming Interface. And what does that mean? An interface is just a way to interact. And in the context of the IPUMS API, we can think of application programming as just meaning using code. So for our purposes today, think of the API as a way to interact using code. So we can think about the API, the IPUMS API, as a way to interact with the IPUMS extract system using code. So here we can see a distressed researcher wondering however they're going to get data from the IPUMS servers. And clearly they need an interface. So until recently, the only interface that was available was the graphical interface of the IPUMS website, where you can point, click, search, add variables and samples, and do all those great things before submitting your extract request to IPUMS and then downloading it from that page once the extract engine has completed its work. The API provides an interface to do the same thing, but using code. And here we can see some snippets of Python and R that define extracts up here on the top and download them here on the bottom. And before I lose all of my Stata users out there, there is a way to leverage Python from within Stata to interact with the IPUMS API from your do files. And I'll point you to some more resources on that later. So if you are a Stata user, please don't give up on this yet. Okay, so a little bit more specifically about the IPUMS API. The IPUMS API is still in development, so I think it's worth just being explicit about what exactly its capabilities are. So with the API, you can define and submit an extract. You can check the status of your extract, or you can use some IPUMS some Python or R code to wait for your extract to finish. You can download completed extracts. You can get info on extracts that you have submitted previously. And I think actually one of the cool things that you can do with the IPUMS API is share extract definitions across with other users. And this is actually something that you can't do with the web interface right now. So what can't you do with the IPUMS API? It's important to note that the API doesn't provide a way to bypass the IPUMS extract system. So requests that are submitted via API are still processed by the same system that handles extract requests from the website. So you do still have to wait for that system to process and prepare your file for download. There isn't currently no metadata access via API, at least not for the microdata collections. So that means if you want to explore what data are available, you still need to do that using the website. You cannot currently access all IPUMS data collections via API. Currently, only IPUMS CPS and IPUMS USA are available this way. We hope to expand API access to other data collections. So stay tuned if there's another one you're interested in. And finally, you can't use all of the features of the online extract system. I will say our amazing product team has been hard at work trying to increase feature availability for the API, and we hope to be able to share those with you soon. But as of today, right now, features like attach characteristics or select cases are not available via API. Yes, but more coming soon. Okay, so you may be wondering if the API is really just another way to do what I can already do with the website, except maybe less. Why should I use it? And it has something to do with sustainable workflows. So first, since the API provides a code-based interface for creating extracts, you can get IPUMS CPS data without leaving your code. It's easy to update your analyses with new samples or to add those variables that you forgot. I don't know about you, like every time I forget to add month and sample to my CPS extract, I always have to go back and add it after the fact. And if you're using the API, that's just as easy as adding that variable to a list. I will say it is still a good idea to check the web documentation. Even if you know exactly what you want, it's always good to check that nothing has changed since the last time you got data. So you don't have any unexpected surprises there. And as I sort of alluded to before, it is using the API makes it easy to share code or extract definitions and enhance reproducibility of your work, right? Like I don't have to click on all of the same things that you clicked on to get the same starting data file that you have. Just some sort of practical points about using the API. You do need to get an API key attached to your IPUMS account, and you can do that at this URL. I also want to flag that IPUMS maintains some tools for helping R and Python users both work with IPUMS data and also to interact with the IPUMS API. They're called IPUMS R and IPUMS Pi, and we'll share some links to further information on those resources for those of you who are interested. I'll be using IPUMS Pi when we return to our example, which is going to be now. So we're going to walk through how to use IPUMS Pi to define our IPUMS extract, submit that extract via the API, wait for that extract to complete, download our data and DDI file, and read that data into pandas. And we're going to do all of that with code, no pointing and clicking. Okay, so here's the extract definition for the data that we were using in our workflow discussion. So here you can see we use this CPS extract class. We pass it a list of CPS sample IDs, followed by a list of IPUMS CPS variables, and we can give it a little description here so we remember what we asked for. Note again that this extract only, or it does contain data up through 2021, but we made no calculations for 2021 poverty rates. And remember, that's because of the difference between the survey year and the reference year for the ASEC data. You'll also notice that year is missing from this list of variables. And that is because year is a pre-selected variable in IPUMS CPS, which means that it will be included in any extract that you make by default. And those same pre-select defaults are included in every API, or sorry, extract submitted by API, as well as those made using the web. Okay, so suppose that we're returning to our analysis 1 year later. The 2022 ASEC data are now available, and we want to add that year to our analysis. So all we need to do to get that updated data set is to add the 2022 ASEC sample ID to our list of samples and resubmit, right? That's a lot quicker and more convenient than trying to dig up our extract from last year and revise it and resubmit it, right? We're just adding this string here. And now with just a few lines of code, we can submit, wait for, and download our extract. So just to talk this through, this submit extract method is going to submit our the extract that we defined in the previous slide to the IPUMS extract system. And this wait for extract is a convenience method that periodically checks in with the IPUMS extract system and asks, is my extract done? Is my extract done? And when the extract system tells it, yep, it's complete, then it tells me that here with this little print statement. And then I can download that data, which will get me the data file and the DDI file, which I will need to read it into pandas. And then we read it in. This is the same thing. These are, this is a method for parsing the XML DDI file that comes with all of your IPUMS extracts. And this read microdata method is going to pull the extract data file into pandas, the extract data file into pandas using that parsed DDI object. And now we can just rerun the rest of our analysis from the top and get an updated plot. You can see this is exactly the same code that we were doing or that we were looking at earlier in our workflow discussion. And now we have that survey year 2022, reference year 2021 observation on our figure here. So you can see that using the API makes our workflow much more flexible by allowing us to easily tweak what variables and samples we are including in our extract. It also makes our work much more reproducible, as we can easily and precisely recreate extracts that we or our colleagues have made previously, and so we can begin our analysis with the same data set without needing to go through all the same pointing and clicking procedures. All right, so I just want to give a little bit of information about some further resources for using IPUMS API and some of those other tools that I mentioned earlier. So IPUMS R is, as I mentioned, an R package that is maintained by IPUMS for reading and manipulating IPUMS data and interacting with the IPUMS API. And here are some links to its documentation, some tutorials and code examples, and a great blog post by Derek about reproducible research using IPUMS R. There is also IPUMS Pi, which is basically the Python relative, I guess, of IPUMS R, also maintained by IPUMS. IPUMS Pi is what I was using in all of the code examples earlier. And again, here are links to library documentation and code examples. And if you're interested in learning more about extract sharing using the IPUMS API, I'll encourage you to check out this blog post that walks you through that. And finally, for the Stata users out there, if you're using Stata 16 or higher, there is support for using Python from within Stata, which means that you can leverage IPUMS Pi to make IPUMS extract from Stata, from your do files. There is a little bit of upfront one-time setup that is required to get that relationship working. But this blog post that I've linked to here walks you through all those steps to get you up and running if that is something that is of interest to you. And that is all I have. So thank you for listening, and I'll be happy to answer any more questions if there are any.